Welcome to Facing Future TV. I am your host, Raya Salter. My guest today is Professor Luis Marquez. He is professor of history at the State University of Campinas near Sao Paulo, Brazil. He is also the author of, among other books, The Decisive Decade, which is due out this spring. Today, he joins us to do a deep dive into the work from The Decisive Decade. Welcome so much, Professor, and for joining us here today.
Thank you, Raya. Thank you for having me.
Of course. And you please go ahead and share your screen so we can get started with the presentation.
Okay, I'll do it. Good afternoon or good night or good morning for everyone. I would like, first of all, to thank again Raya and Face Future Earth TV for this invitation. I'm very pleased and very honored to be here with you today. I will talk, as she just said, about acceleration, about the decisive decade, and marked, by all means, by the question of acceleration. And I will try to follow, this arrow you have in the top of the screen in seven points. And the first one is also, of course, the fossil fuel production. So acceleration one is exactly this, fossil fuel production. And as you can see, half of all fossil fuels burned in human history have been burned since 1990, when the IPCC published its first assessment report, and when we were therefore already fully aware of the climate crisis. See this graph shows exactly 82% since 1960 and 40% since 1990.
Incredible.
Acceleration two, of course, if you burn fossil fuels, you have carbon emissions. So roughly 54% of all CO2 anthropogenic emissions emitted since 1750, the Industrial Revolution, have also been emitted between 1990 and 2020, as you see in this graph too. Of course, number three, acceleration three, the rise of CO2 atmospheric concentrations. So CO2 is now reaching 50% above the pre-industrial levels. We were in 278 parts per million, roughly during the pre-industrial period. And now we hit 1,417 parts per million, more or less. It's a little bit this kind of little variation along the year, but in the average is 417 parts per million. Regardless of the climate negotiations from 1992 to now, so you have here in this graph exactly the Rio Summit, then the Kyoto Protocol, the Copenhagen Accord, the Paris Agreement, now the COP26, which was a little bit a big fail.
Absolutely, a lot failed.
Yeah, terribly failed, and we can just follow this acceleration. In the first period, during the 60s. We are growing at a rate of 0.9 parts per million per year in average. In the first decade of the 21st century, we were already in a growth of 2 parts per million per year. And now we are in the second decade, we were in 2.4 parts per million per year. And if you take just the last period, 2015, 2020, we were at average in 2.54 parts per million per year. So we are just accelerating terribly. And this is an extrapolation of this. So in April 21st, we have 21, we have 419 parts per million. And if you make kind of a simple extrapolation, in 2031, we will have 451 parts per million. And normally, 450 parts per million is associated to a warming of 2 degrees Celsius above the pre-industrial period, which is extremely dangerous, as we know. Acceleration 4, the increase of Earth's energy imbalance. The Earth has been in radiative imbalance, so more energy is coming in than going out. This is the radiative imbalance. Since the 1970s, since the 1970s, this imbalance began. And the Earth's energy imbalance is not only continuing, but it's also increasing. It's also increasing. So we are now at about one watt per square meter in each square meter of the Earth's surface, which is extremely problematic. If you see this graph, it shows exactly this, and which element of the Earth system is taking this imbalance more? Of course, is the ocean. Ocean takes like 91% of this acceleration. If you see, this little part here at the bottom of the graph, this is the atmosphere. And this is just a small fraction of the Earth energy imbalance, represents already 1.2 degrees Celsius before in the average, superficial average above the pre-industrial level period. And so if there is a small difference in the ocean, or the more superficial ocean or not, there will be a big impact on the warming in the surface, in the atmosphere. So it's extremely dangerous already. And then we go to the acceleration 5. Of course, it is the kind of a chain of consequences, and we have a rise in temperature. And so this graph shows you the global warming since the year 1 of the Common Era. And you see that during the last 2,000 years, we were a little bit the same. People say a little bit about the question of the little ice age here. Indeed, you have just a little cooling, of the average temperature of the Earth. But if you see just about the 21st century, we get already 1.2 century. And this is a kind of jump. It's a very, very rapid. The problem of warming is not the difference of temperature. The problem is the
acceleration.
The speed, exactly, the speed.
Professor, if I may ask you, this is stunning to me, because as somebody who has looked at these systems as well, I have seen it as that trend, like you put the invention of the steam engine. But what you're zeroing in on is that, yes, it has been in just a few generations, but boy, it has been since 1990 and since 2000. This acceleration is more recent, I think, than most people realize.
Absolutely, absolutely. If you want, until the 70s, the warming was not really accused in the instrumental measurements. It's after the 70s that really you have. I'll just show you exactly this. Look, this is the global surface temperature relative to 1880 to 1920, the mean, the average. And in this graph, you have what? You have, this is the red line, and the red line is the variation of the temperature each 132 months, because there is small variations in the sun cycle. And so this red line is just to ignore, this variation in the cycle of the sun. after, you see, after the 70s, what you have, there was here a little bit, of warming if you take this and compare to this. But since the 90s, you have just a first phase of acceleration. And during the first phase of the acceleration, so since the 1970 to 215, you have a warming at the rate of 0.18 degrees Celsius per decade. But look, and the green line, is the best linear fit. And since the 2016, what you have here, you have a jump. So we go above the best linear fit. And so we enter in the second phase, and the second phase of this acceleration. And in this second phase, we are warming at the rate of 32 degrees Celsius per decade. And the projections show us that between 2016 and 2040, we probably will accelerate at the rate, warm at the rate of 0.36 degrees Celsius per decade. This is really what we can say about acceleration. This is a kind of,
this acceleration. And it's happening now.
It's happening
now.
Exactly.
And people in their mind think it's other people, old people did this, and old people did, but it's what we are doing right now. Yeah, and it is causing significant damage.
It's not anymore in the future. It's really in the present days. And then we go to also the temperature, but in the terms of the heat waves and new temperature records. And this is NOAA, the National Oceanic and Atmospheric Administration. And what they say, from 1900 to 1980, a new temperature record was set on average every 13.5 years. But since 1981, it has increased to every 3 years. And if I had time, I could show you, but we can do it all the time, all these new temperature records since the 2015 to our days. And it is really stunning.
And it's, wow. And it's fossil fuels that we'll talk about. And it's agriculture, it's, it's pollution, it's so many things.
Exactly. And then we reach one of the consequences of this global warming is, of course, the global sea level rise. So this graph shows us this. So from 1993 to 1997, we were, the global sea level rise was progressing at a rate of 1.5 millimeters per year in the average. And then you have from 1998 to 2012, 3.2, and then from 2013 to our days, 5 millimeters per day, and from 2018 2019, global sea level rose 0.24 inches or 6.1 millimeters per year this year. So what is I'm telling you is that this is accelerating exponentially. This is an exponential acceleration of the global sea level. And James Hansen, which is kind of a patriarch of the climate science, wrote with a lot of colleagues you have seen the bottom of the image, ice melt, sea level rise, and superstorms. And what they say is we hypothesize that ice mass lost from the most vulnerable ice, sufficient to raise the sea level several meters, is better approximated as an exponential than by a more linear response. Doubling times of 10, 20, or 40 years yield multi-meter sea level rise in about 50, 100, or 200 years. So now we are in 2050, like 300 million people in the Asian continent, who now lives in the part in a territory that will be flooded during the high level or no of the sea, the high tide. Again, Robert de Conte says, today we are measuring global sea level rise in millimeters per year. We are talking about the potential for centimeters per year just from Antarctica. So just from Antarctica. And finally, climate damage. The most important climate dangers now is the wildfire, the wildfires. And people are talking about the advent of the Pyrocene. The Anthropocene would be called also a Pyrocene. The more we burn, the more it burns. So wildfires are globally getting worse. From 1979 to 2013, the global area of forest fires has increased by 29.6 million square kilometers, or 25% of the planet's vegetated area. This is a paper published in 2015 in the Nature Communications. This is a graph of this paper. You can see, so long fire weather seasons affected area. And you see from 1980 to 2013, and you see clearly the kind of rise we are having now. Wildfires are getting worse in the United States. Now, the number of wildfires is increasing, and they are burning more land. This graph shows you more clearly way from 1983 to 2020 in acres. 11 million acres of land are burning in the United States, and not only in the United States, also in Europe. Fires burning more land in Europe. This is 20. The red line is 2021, and the average 2020 is the other line, the blue line. And you see, of course, the jump is more than acceleration; it's a kind of jump. Also in Siberia, so you take from 2016 to 2021, you have this is measured in terms of carbon emissions, and not in land or focus of fire, but in terms of carbon emissions. And you see, of course, so the rise is impressive. Also in Australia, you see from the 19th century to our days, are getting worse in Australia. And in Brazil. And in Brazil, it is a little bit different because it's not wildfires because of climate change, but it's because it's set fire by the agribusiness, or by, most of all, by Bolsonaro, the president of Brazil now. So in Brazil, so this is an article, published by The Guardian, Chaos, a journey through Bolsonaro's Amazon Inferno. So this is deliberately done. It's not it's not simple question of climate change. And policy, drought, and fires combine to affect the biodiversity in the Amazon basin. This is extremely important, This is how the wildfires are getting worse in the Amazon just in the months of June. But this is still more important. Of the 17 mega diverse countries in the world in terms of biodiversity, 5 are in the Amazon. Brazil is the first one, then Colombia, Venezuela, Peru, Ecuador. And 95% of the species are affected because rainforests are not adapted to fire. So when it takes fire, when it set fire, the forest is completely destroyed. It's completely destroyed. And finally, the potential liability. We have no evidence that 1.9 degrees Celsius of warming is something we can easily cope with. And 2.1 is a disaster. And we are just accelerating toward this level of warming, So this is why I chose this title. The next few years, the next decade, will be the most important in human history. This is the Professor Sir David King, as government chief scientist in the United Kingdom. What we do over the next 10 years will determine the future of humanity for the next 10,000 years. Thank you very much.